Hi and welcome everyone. This video I want to go over the derivatives of functions and mostly I want to talk about the definition, the limit definition of derivatives. Now the derivative of a function at x equals to a, this is a fixed point, can be found by using this formula. First of all, the derivative is, as we saw, it's f prime of a. So you can say f prime of a equals to limit as h approaches to 0 of f of h plus h minus f of a over h. So, or you can also use this formula. You can say limit as x approaches to a of f of x minus f of a over x minus a. I will do a couple of examples, an example by using both so you can see how we can find the same number. And this is also, we know that the derivative at point A, it's also the slope of the tangent line at that point at x equals to A. Now, if you want to find the derivative as a function, if you put x times the derivative of the function at any point x can be found by this formula. Limit as h approaches to 0 of f of x plus h minus f of x over h. Now, please be careful with this note. A function f of x is said to be differentiable at x equals to a if the following limits exist. Well, we saw already that the limit as h approaches to 0 of f of h plus f of a plus h minus f of a over h. When you calculate that limit, it has to exist. If it exists and it's a number, then you say f of x is differentiable at x equals to a or the given point. Or the second one, these two are going to give us the same result. F of x, the limit as x approaches to a of f of x minus f of a over x minus a. Now to see this better, let's go over an example. I picked a very simple function. So let's say f of x equals to x squared and find f prime of x, number one. So f prime of x is the limit as h approaches to 0 of f of x plus h minus f of x over h, the substitute. And don't forget to put limit each time. Limit as h approaches to 0, our function is x squared. So you write x squared plus h squared, which is that part, minus x squared, which is the function itself. And you can expand x plus h squared to get x squared plus 2xh plus h squared minus x squared over h. And if you simplify, x squares cancel, so you're left with 2xh plus h squared over h. You can factor an h from the numerator and cancel the h's. So you're left with 2x plus h and simply substitute h by 0 and you get 2x. So the derivative of this function f prime of x equals to 2x. Part 2, let's find f prime of 1 and for the same function. One way of doing this, you can just go to f prime of x and instead of x substitute 1, it's 2. How can we find this? By using the formulas. Let's go ahead and do that. So I can say f prime of 1 is limit as h approaches to 0 of f of 1 plus h minus f of 1 over h. And that's limit as h approaches to 0. X squared is 1 plus h squared minus 1 squared over h. 1 plus h squared is 1 plus 2h plus h squared minus 1 over h. And again, 1 negative 1 cancel. You have 2h plus h squared over h. You can factor out the h from the numerator. So you're left with h times 2 plus h over h. H is canceled. And if this approaches to 0, then you get 2, which is the same answer. Now let's use the third formula. We said f prime of 1 We can also do limit as x approaches to 1 of f of x minus f of 1 over x minus 1. If you substitute our f of x, again, it's still x squared. So you can say it's x squared minus 1 over x minus 1. So here, if you try to find the limit, you get 0 over 0, and this is the indeterminate form. And this is pretty easy because we can factor the numerator. The numerator can be written as x minus 1 times x plus 1, the difference of two perfects squared. If you factor those, and that's over x minus 1. X minus 1s cancel each other, so you're just left with this function, and if you substitute 1 by x, you get 2. So in all three ways when we solved, we saw that the answer is 2. Here we got 2, here we got 2, and also here we got the same answer, which is 2. Now, the second part of this problem, it says find the equation of the tangent line of f of x equals to x squared, same function, at x equals to 1. So just a note here, from algebra, we learned that the equation, the point slope formula, or the equation of the line can be found by using this formula. Y minus y1 equals to m times x minus x1. In calculus, our y1 is just f of a, and m is the slope of the tangent line, which is f prime of a, and x minus x1 is just a. So these two are the same equation, but however, in calculus, that's how you write it. And this is equation of the tangent line at x equals to a. Let's see how we can find that with our function. If we have f of x is x squared and x equals to 1, that means a equals to 1. Find f of 1 first, which is 1 squared. Just substitute 1 here. You get 1. F prime of 1, we calculated that it was 2. So you just write y minus f of 1 equals to f prime of 1 times x minus 1. And if you isolate y, you get f of 1 plus f prime of 1 times x minus 1. F of 1 is 1. F prime of 1 was 2, and you write 2x times 2 times x minus 1, simplify, and you get 2x minus 1. So let's see what that is. Y equals to f of x equals to x squared. That's a parabola, we know, the vertex being at 0. We want the equation of the tangent line at that point. And we know it's 2x plus 1. If I graph that line, and we can use slope and y-intercept. So, and that's minus 1. So basically the y-intercept is -1, so you go down 1. That's the y-intercept. And the slope is 2 over 1. You go up 2 and over 1. And you just connect these 2 points. And that's going to be the equation of the tangent line at that point. This line touches 1, only 1. So even if it doesn't show on the graph at that point, and this is the tangent line at that point. I think that's it for this video. I want to make those videos short. In the next videos, I'm going to talk about rules of differentiation and do more problems to see if a function is differentiable at a point or it's not, and when it's differentiable and when it's not differentiable. Thank you for watching, and have a good one, everyone. I'll see you in my next recording.